engineer. Welcome to my channel. In today's video, I'm going to be exploring the Terraform architecture alongside some example Terraform configuration code, and also run the Terraform configuration code in practice and actually deploy some resources out in AWS. So the reason behind doing this video is, so first of all, today there are actually some really good videos already out there in YouTube that explains the theoretical concept behind Terraform really well. However, those videos are currently missing a link up between the actual theoretical concept and the practical deployment of some resources from alongside some Terraform configuration code. I've had fair amount of junior DevOps and platform engineers that are starting to get down the route of Terraform for their work purposes. Tell me that they understand the theoretical concept behind it, but when they're trying to actually implement Terraform on their day-to-day kind of activities, they're still trying to kind of struggling to understand the relationship between the practical implementation and the actual theoretical concept behind the Terraform architecture, which is why I thought I would make this video and try to address that gap. So there will be, I'll start with this diagram, but there will be a fair amount of back and forth between this diagram, my VS Code, and the AWS console, so just bear with me. So on the left hand side of this diagram, I've got the key features of Terraform, and on the right hand side, I've got the actual physical components of the architecture that enables Terraform to do what it does so well, right? Now, to start off with, let's look at the declarative feature, right? What is this declarativeness? Now, when we say a declarative language, in this particular case, declarative feature is really just a declarative language of Terraform. What we are really saying is that I have just declared a state, and that's the state I want to be able to get to without following any further step-by-step instruction or having to detail it all down. Which is kind of different from traditional programming. So for example, when we're iterating through an array, right, we're using some for loops, and then if there is some condition or we're checking for a specific element in the array, we're adding some condition in. So there's some logic that does step-by-step manipulation of some resources, right? Whereas declarative is on the contrary, they are more just about, don't give me any step-by-step details, I don't want to know. Just tell me what you want me to do. So put the coding world a bit to the side and think right from a normal life point of view, right? Think that you're trying to make creamy chicken pasta and you've never done it before. You're most likely going to be following a recipe which will have some step-by-step instructions on how do you go about making creamy chicken pasta. Now compare that to you going to a restaurant instead and ordering creamy chicken pasta. You don't need step-by-step instruction anymore then, because the food or the pasta gets delivered right onto your table. You just have to ask for it or order for it. And it's the same analogy in the programming world between declarative and traditional programming, right? Now to just quickly show in the actual code, in here, in order to create an S3 bucket, it's as simple as just giving a name of the bucket, right? I don't have to worry about other programmatic issues. For example, I don't need to worry about getting an S3 API endpoint, or first making sure that the bucket already exists or not, and then adding some error handling check for that, or also making sure that the name of the bucket complies with AWS S3's bucket naming convention, and stuff like that. And there will be a lot more checks that you could do, right, when you're writing code and stuff like that. That in Terraform is pretty simple. All you need to do is just give the name of the bucket, and Terraform takes care of the rest. And this is just a primitive example, but think trying to manage virtual private clouds, EKS, so your Kubernetes clusters, virtual machines in general. Things can get quite complex in today's world, or businesses in today's world that are currently using cloud to manage their infrastructure, right? Or to host their infrastructure. And that's why something like Terraform, which is declarative, makes it very easy, because since it's configuration as code, right, it's very easy to follow, easy to read, easy to maintain, and easy to understand. And makes really life simple as a platform engineer. The next feature is portable. Now, portability comes in kind of two key points, really, when I say portable here. So first is cloud agnosticness. So you can use Terraform to manage multiple cloud providers or resources in multiple cloud providers at the same time. Not saying that you can migrate everything from AWS to GCP, for example, through a magic button in Terraform. That doesn't work. You still need to do a lot of work for that. But you can definitely and certainly manage multiple cloud deployments from one single place. So unless your business already has a very strategic fixed decision on a particular cloud provider, you most likely want to use Terraform, right? Because you want, even if you're not using multi-cloud straight away, that means you need to be open to be able to work with other cloud providers, and Terraform just makes things easy to migrate, if not a full lift and shift. I mean, these cloud providers have their own kind of Terraform equivalent. AWS has got CDK, Azure's got ARM, GCP has got Deployment Manager, but they are specific to their own, right? Whereas Terraform comes and sort of allows you to maintain multiple in one go. And another feature cooler with that goes with portability of Terraform is that you can use the same, you can reuse the same configuration code that's for your, let's say, dev environment in AWS, and you can use that to create a QA environment and also in prod environment. But on top of that, apply your independent environment specific resource constraints or modifications as well. So you can basically you can reuse bulk of the code configuration that you define for one environment in another. Terraform makes it simple, and the DevOps feature of the architecture is sort of goes hand in hand with that. It's not really a feature, I would say, just the best practices that Terraform allows DevOps engineers and platform engineers to sort of build into the pipeline and in their ecosystem. So, for example, when everything is defined in code, it just naturally becomes very easy to review changes, or you can have code reviews carried out on there, and that it also enables you to have a very controlled and secure deployment of infrastructure, right, through the usage of CI/CD pipeline. But most importantly, it just automates things for you and shapes it up for being used as a developer self-service or IDP, so internal development platforms. I'll cover self-service and developer self-service specifically, and independent internal development platform in future videos. If you want more information on that, just leave a comment on the video and I can address them. But anyways, that's the DevOps side of the things. Now jumping onto the physical components of the Terraform architecture. So these are the more fundamental blocks, you can say, of the Terraform architecture. So the first one is configuration file. So configuration files can be as simple as just this, right? And you can see in a configuration file, I've got a few specific keywords, and these are just Terraform specific keywords that you need to use really in order to, for example, in order to provision a resource, I need to use a resource block, and these resource blocks are published for specific providers. So AWS has got one for bucket, one for user, for example. GCP is going to have similar for their cloud storage buckets, and AWS, AKS are going to have their for storage accounts equivalent resource blocks. But these are just keywords. Same for provider. I'm using AWS providers for EU region, and I'm also saying that I need to use AWS provider APIs basically. So to go into there, so before I jump on that, there's Terraform Core, which is another core physical component of the Terraform architecture. So Terraform Core is basically your Terraform CLI. So for example, if I go and run Terraform version, I'm actually utilizing Terraform Core. Sorry. Why is that? Of course, because I put Terraform. Yeah, so It's just a spelling mistake, that's all. But anyways, that's utilizing Terraform Core. So Terraform Core is basically anything that you can interact with from Terraform CLI. So all of the most used ones are Terraform Plan and Terraform Apply. What the Terraform Core does is that it communicates. So when you run Terraform Plan and Terraform Apply, right, you are actually making the Terraform Core communicate with the provider's API. And the provider's API is going to be specific to what resource your configuration file is trying to create. In my case, it's going to be using the AWS provider API. And the AWS provider API is then actually going to be, and it actually, to be honest, this Terraform state should really be here. So if I make a quick modification to it, because essentially Terraform Core is communicating with both of them. It's using the provider API to sort of make a read if you're running Terraform Plan. If you're doing an apply, it's a read write. But it's reading, performing a read, and then it's looking at the state to figure out, right, what do I already have under Terraform management and what I don't. And based on the information from both the provider's API and the Terraform state, Terraform Core can then display out in the console what, if there are any changes, what exactly are going to be the changes, basically. And we'll see that in action now, actually. But before I do that, the first thing I need to do is that I need to do Terraform init. So without Terraform init, these resource blocks in here, they don't really mean anything, right? Because I don't have the actual provider APIs that are required behind the scenes to create an AWS user or AWS S3 bucket. And Terraform is not really going to let me do anything with it, right? So for example, if I do Terraform Plan now in here, I'm already basically blocked from Terraform by this stage. So if I do Terraform init, it's now going to go and get the latest version of AWS providers APIs. You can version control it, but I've left it to with no version constraint in here. So it's just pulling the latest AWS provider APIs. But if you want to version control it, you can just put a version keyword in here and do so. Again, if you want any information on that, just feel free to drop a comment. But essentially, Terraform has successfully been initialized, means the provider APIs for AWS are now present, which basically is stored in this Terraform file. And you can see there is a provider AWS executable. Now, if I go and actually run Terraform Plan, what this is going to be doing is that it's going to be taking the input information from my config file, which is this main.tf. Now, one side note on this TF files is that Terraform, when I say configuration files, Terraform is really concerned with just files with .tf extension, but more specifically a file named main.tf. You may have heard about concepts such as Terraform modules, then output.tf, locals.tf, variables.tf, and so on. Those are more of, you can think of them as a decoration of your main, that's on top of your main.tf file, right? It makes it easy to maintain and manage a main.tf file. As you maintain a complex set of infrastructure, your main.tf file can otherwise get really big, and you may need to do a lot of reusability of your code. For example, if you were to create like 30 virtual machines, right? You don't want to be writing the same block again and again. And that's where modules come in quite handy, variables come in quite handy, especially again, tying back to developer self-service and building an internal development platform. You really need to keep those decorations in mind. They're fundamentals. But in principle, to get Terraform to actually work and create resources and basically follow through the core parts of the architecture, you don't really need to have all the decoration surrounding it. So this configuration file is going to be going as an input to Terraform Core when I run Terraform Plan, and Terraform Plan is going to be then using provider's API to perform a read request to AWS and get the required information based on the resources defined in the config. And then it's also going to be looking at a state. So I'm using a local backend at the moment, so my state at the moment is just empty, and you can use the backend based in S3 as well. So I'll cover a future video in which I'll actually go into the pros and cons of backends and workspaces So if you're interested, just leave a comment. And if you, as in like, if you want anything specific to be covered in that video, then leave it as a comment in the comment section for this particular video. But essentially now this is what Terraform Plan is going to be doing. So if I run it, it's basically following this kind of flow chart, you can say, and in terms of using the physical components of the architecture. And the output basically gets displayed from Terraform Plan into the user's terminal. So you can see that Terraform, since my state is empty and I've only got these two configs in here, which is to create a user and to create a bucket, Terraform will just come back as expected, saying that 2 to add and 0 to change, 0 to destroy. So I'll just go ahead now and do Terraform apply, which is basically going to run the plan again. It is a very kind of robust or resilient feature built into Terraform. Go ahead and put yes. Robust feature in Terraform to make sure that in case there is a certain drift in between running the plan and the apply, that when you're applying actually doing Terraform apply, you are not missing anything out. Obviously, when you're running it from an automated pipeline, you don't want to really do that. You would rather want to save the plan somewhere as an artifact and then reuse the plan when you're doing the apply. So you can pass in a save plan from previous run and use that. And that's more safer because that just makes sure that there is no errors or conflicts that are arising. But again, fundamentally, that really shouldn't happen if a Terraform pipeline is pretty much controlled. And more importantly, if everything is managed to Terraform, then there should not be really any drift, as everything is going through a Terraform state and provider's APIs at that point. All right, what's the problem here? Creation complete after 1 second. I'm getting it from the bucket. Huh, interesting. Bucket already exists. Why would the bucket already exist? Let's have a look. Maybe I have got only one bucket. Did I not change the name? Test bucket, test user. Nope, that doesn't look right. Let's run it again. See what it comes up with in the plan. Seems like for some reason it's trying to create it again. Could just be a transient issue, to be honest. So it's trying to create this bucket, which I do not really have at the moment, so I'll go ahead and give yes. Which could make sense because it could be a global namespace. So somebody else could have created it already, right? Since buckets are global. So I'm going to give it, let's say, platform engineering, and see if that works. And yeah. Yes, let's go. There you go. Now it's done. So it's just a name. I just had to give it a more unique name, basically. So now if I go in and if I refresh in my bucket, I can see that I've got this bucket created, and I have also created a user. So let's go into the IAM. And in IAM, if I go into the users tab, I should be able to see now a test user being created as defined in my configuration, right? And fundamentally, this has really just used the principle that's defined in my physical, in this architecture diagram. So config files, Terraform core, provider API, and Terraform state. These 4 physical components together enabled us to create this S3 bucket and create this user based on the configuration in here. Now let's say in my current test kind of setup in here, I actually want to enable the user now permission on the bucket. So I'm just going to go ahead and give them ability. Currently, the user that's been created in here has got no permission. So if I go in, you can see the permission policies are empty, right? So they are not going to be able to interact with this S3 bucket or any S3 bucket really at this point. So I now want to go in and give an ability to the user to be able to access this bucket that I've just created in here. Now to do that, I'm going to just uncomment this block because I've already pre-wrote that. Now data block is another concept or a keyword in Terraform language or HCL. What data blocks do is it requires information from an, you can say, a data source that already exists outside Terraform, and it takes in some query parameters based on which it can basically return data for you. So in this particular example, what I'm doing is that I'm basically querying the AWS IAM policy for S3 buckets, for S3 specifically, I'll say, and I'm creating a policy that allows access through a wildcard for S3 buckets, right? You can have specific actions in here. So just to show what this really could be, AWS IAM policy actions, just Google that, and just to fundamentally show what actions are available. And it's the same concept for any AWS resource and services really. And Google Azure has got similar kind of things really. So if I just search for S3, so actions defined by S3, right? So I have basically, just for the purpose of this video, I've created an action that's basically allowing wildcard. That's a wildcard, so it's actually allowing all actions for S3, which is basically everything that you see in here. Obviously, this is not something it's recommended in production, right? But for the purpose of this video, that's fine. But I could specifically just put abort multi-part upload, for example, as an action, and paste that in here, right? So like this, abort multi-part upload. But instead of that, I just put wildcard to give all access over S3. And as resources goes, I could specifically give permission to a specific bucket. So I could explicitly say this bucket's name in here as well, but I put a wildcard too. Because for the purpose of this lesson or this demo, it doesn't really matter too much. Now, once I've defined this policy, all it's doing is basically set up an AWS policy based on it queried these actions. So in this case, every action basically for S3 and all the resources that exist in S3, essentially. Now, this data source by itself doesn't really do much for me in order to provide or satisfy the use case of user being able to access the buckets in S3. So what I really need to do, which is the last piece, is to tie in this policy with a resource called AWS IAM user policy, and this would then link with the Terraform user.name, which is incorrect in here because I've called it test user. So let's go and put that. So it's going to be able to use the user that I've just created and get the name of that user, and then based on that information and based on this policy data source that I've defined here, it can tie them together, and then this user is going to have permission on bucket. So let's go ahead and run Terraform plan again, which is again going to follow through the core physical components that I highlighted in this diagram. So again, configuration file has got new information now, and this information gets fed back to Terraform core when I run Terraform plan. And Terraform plan then basically uses the provider API to perform a read, and then looks at the state and then figures out it needs to add one resource, which is the policy as expected. So let's go ahead and hit an apply on it, which is basically going to do the same thing again and generate the plan. So let's give it a moment, and once we have deployed it to Terraform, I will be expecting a permission set to now be present for this test user in here. So this shouldn't be 0 anymore, and this should be a permission for S3. So that's done. So let's go ahead and refresh it, and there you go. We've got a Terraform user policy, and in that policy you can go and check that they've got permission on S3. So yeah, so that is an overview on the Terraform architecture, alongside some side-by-side simple, very simple, primitive Terraform configuration, and some example deploys in AWS environment to satisfy the use case of a user having an access on an S3 bucket. So if you have benefited from this video, then please feel free to give a thumbs up to the video, and also subscribe. Moreover, if you want to stay alert on any future videos, then yeah, feel free to hit the subscribe button. I'm going to be covering more on Terraform in my upcoming videos, and also go into detail, as I highlighted earlier on, for developer self-service and internal development platform, and Terraform will be a key part of it. So if you're interested in things like that for platform engineering, then make sure that you hit the subscribe button and stay tuned for new videos. And like always, thanks for watching, and if you have any questions, anything is not clear from here, you want me to go over or explain a bit more in another video, then just feel free to leave those comments in the video's comment section. Thank you very much. Bye.